The range is the difference between the maximum and minimum values. All the data are within the interval of this width. The interquartile range is the difference between the upper quartile and lower quartile. Half of the data lie between the two quartiles. So an interval of this width includes half the data. The range of the data set only depends on the minimum and maximum values, and therefore a poor summary of the spread of data. The interquartile range is therefore a better summary of the spread marks middle 50% between upper quartile and lower quartile. To do this, you work out the median, which is 50% of the data, has 50% data either side. N plus 1, and then divided by 2 equals the position of the middle value. N equals the number of the pieces of data. The lower quartile is 25% of the data below this. N plus 1, then you divide all of that by 4. And the upper quartile is 25% of the data above this. 3 times N plus 1, then you divide it by 4. Worked example, if the range is 31, then you minus 3 equals 28, then 11 plus 1, then you divide that by 2, equals the 6th position, which means in that data value, it means 8. Lower quartile, 11 plus 1, which is 12, then divided by 4, equals 3, so that's the 3rd position. And then you go along the data, and that would mean the lower quartile is 4. The upper quartile is 3 times 11 plus 1, then you divide by 4, and that equals 9, and the upper quartile equals 11. Standard deviation. In statistics, standard deviation is a measure of the amount of variation of distribution in set values. A low standard deviation includes the values tend to be close to the mean of the set, while higher standard deviation includes that the values are spread out over a wide range. It is calculated as the square root of the variance by determining the variation between each point of data relative to the mean. If the data points are further from the mean, there is a higher deviation within the data set, thus the more spread out the data, the higher the standard deviation. The that is the sum of that E shape, and the X with the bar there is the mean. X is the individual values, and N is the number of data values in the set. So there's a worked example of it. Quantitative data analysis techniques in differential statistics. Pearson's rank order. So this is the test for correlation, Pearson's rank order. There's a worked example of it. That's how you calculate the R value. Then you use this chart to see if it's significant or not. And the significance is 0.5. And so you go down to the 6th value, and then that's what you get. Spearman's rank order. This is the equation used. Those are the data sets and what N is and the deviation is worked out. There's a calculated R value, and then you go on to see if it's statistically significant or not, again by the 0.5. Here's a dependent t-test. There is the equation used, and you work through it, and then you find out all the values. For instance, N is 6, and you go through for the rest of them, then you just put them into the equation, and then here it is put into the equation, and you work through it until you get your calculated R value. Here's again how to work out the significance on a critical values table, and significance is 0.5, and it's a two-tailed test, and then you work it out, and this one is not significant. Here's an independent t-test, and again you work through it, and the equation's there. Then you work out what M1 is and M2, and then you plug in the points of it to find the calculated t value of what it is, and then see if it's critical or not, and the deviation is 0.5. Then it says if it's significant or not.